So we're going to talk about intermolecular forces and solubility in solutions. And it turns out that the rule for solubility is like dissolves like. And what this means is things with the same intermolecular forces are soluble. Okay, so you need to have the same type of intermolecular forces. And for us, we only consider London or van der Waals, dipole-dipole interactions, and H bonding. And so to do this, you're going to have to be able to predict what type of intermolecular forces a compound has. So for example, I might ask which of these compounds are more soluble in water. Okay, so here's my four compounds: CH3, CH2OH, CH3, CH2, CH2OH, and CCl4 and H2O. I should give the Lewis dot structures for these. There's the Lewis dot structures over to the right. And so we'll start talking about what intermolecular forces they have. So CH3, CH2OH, ethanol, has London, it has dipole, and it has hydrogen bonding. CH3, CH2, CH2OH has the same thing as London, but it has more London, dipole, and H bonding. And CCl4 only has London. And the question is, which of these three are more soluble in water, which has London, dipole, and H bonding? It has a lot of H bonding. So clearly, we got to throw this one out because it only has London, and like dissolves like. And while they all have London, this also has dipole and H bonding, and it has a lot of dipole and a lot of H bonding. Now, when we look at these two up here, they all have London, dipole, and H bonding for these two, but the percentages of them are not. So this has more London forces over here. This section of the molecule has a greater percentage of it as being London, and a lesser percentage being only this little bit out here is dipole and H bonding. And even this compound has the CH3, CH2OH, the ethanol, the one in red up here. It has a fair amount of dipole and H bonding. It is more dipole and H bonding than CH3, CH2OH. So this one has the greatest percentage of dipole and H bonding, and that's what water mostly is. So we would circle this one as being the most soluble. And that's what we do in this. You're going to get a bunch of questions that ask you to look at the solubility. So here's the next question. The question's going to ask which of these compounds are more soluble in pentane. And the two compounds are carbon tetrachloride and chloroform. Okay, and so we'll look at these. First, we look at pentane, and we notice that it's just a bunch of CH3, CH2s bonded together. So we'll have our 5 carbons this way and filled up with hydrogens everywhere else. And so there we have it. And we know from previous sections that this is almost completely nonpolar. And so this compound is completely nonpolar, so it only has London forces. Well, carbon tetrachloride has London, and that's it. Remember, this is three-dimensional: C, Cl, 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 and one back here, and they cancel. And HCCl4 is three-dimensional also, but this one's going to be slightly polar, and so we expect the solubility of carbon tet, which only has London, to be more soluble in this compound that only has London forces, where this one has London and some small amount of dipole. So these are the kind of questions you'll get on the exam. You'll have to figure them out. You need to learn to recognize these compounds like that for these type Lewis dot structures over here. Okay, I'll give you another couple.